Good evening, students. Now we shall continue with the problems which are based on complex numbers. In the last lecture we have seen the identities related to the complex numbers. Now we shall be expressing the given complex numbers in the form of z is equals to a plus ib. We shall be expressing it in the form of z is equals to a plus ib. Now I take the first problem as this: minus 5 times I into 1 divided by 8 times I. So I need to express this number in the form of z is equals to a plus ib. For this, what I will do is I will multiply it. So minus 5 by 8 into I square. So that will be minus 5 by 8 into I square. I know that the value of I square is minus 1. So this will become minus 5 by 8 into minus 1, which is 5 by 8. 5 by 8 happens to be a real number. So this can be written in the form of a complex number as 5 by 8 plus I into 0. So if I compare it with a plus ib, the value of a is 5 by 8 and the value of b is 0. The value of a is 5 by 8 and the value of b is 0 here, right? Now the next one that I will be taking up is, now the next problem that I will be taking up is this one: 3 into 3, that is 3 into 7 plus I times 7. 7 plus I times 7 plus I into 7 plus I times 7. So what is common here? So common here is 7 plus I times 7. So it is 3 plus I into 7 plus I times 7, which is equals to 3 sevens are 21 plus 3 sevens are 21 times I plus 7 times I plus I square into 7, which is equals to 21 plus 7, 28 times I minus 7. So that will be 21 minus 7 is 14. 14 plus 28 times I. So this is the form of a plus ib. Here the value of a is 14 and the value of b is 28. So here the value of a is 14 and the value of b is 28. Now the next one that we will be seeing is this problem: 1 minus I. Next problem is this: 1 minus I minus of minus 1 plus 6I, right? So this is the problem. So here this will be equal to 1 minus I plus 1 minus 6 times I. So 1 plus 1 is 2 minus I minus 6I is minus 7I. So if I compare it with a plus ib, here the value of a is 2 and the value of b is minus 7. Here the value of a will be 2 and the value of b will be minus 7. Next one that we are going to take is, next one that I will be taking is 1 by 5 plus I into 2 by 5. 1 by 5 plus I into 2 by 5 minus 4 plus I into 5 by 2. So this will be equal to 1 by 5 plus I into 2 by 5 minus 4 minus I into 5 by 2, which is equals to 1 by 5 minus 4. Here I is common, so it is 5 by 2 2 by 5 minus 5 by 2, which will be equal to, here 5 is the LCM. So 1 minus 20 plus I into 10 is the LCM. So 5 2s are 10, but 2 5s are 10. So 10 minus 10. So that is minus 19 by 5 plus I into 0. 10 minus 10 is 0, 0 upon anything is 0. So this is how you express it in the form of a plus ib. Now the next one that we will be seeing is I raised to minus 35. I raised to minus 35 is the next problem. Now these are with only one I, right? So if you can look here in this I raised to minus 35, this is the problem, that is I raised to minus 35. So this, if it is a negative index, what we are going to do is we are going to take it to the denominator, that is 1 divided by I raised to minus 35. So this 35 I will be writing it as I square raised to 17 into 1 using the theory of indices. I know that I square is minus 1. Minus 1 raised to an odd power will be minus 1. So it is minus I. And this I will be rationalizing. So here I will be multiplying and dividing it by I. So that will be I divided by I square. I divided by I square, so that is equals to I. And how this is minus I, that I will be telling you. So here you are getting it as 1 divided by I square raised to 17 into I, which is equals to 1 divided by I square into raised to 17. So that will be 1 divided by minus 1 raised to 17 into I, which is 1 divided by minus I, because minus 1 raised to 17 is minus 1. Minus 1 into I is minus I. So into I divided by I. So that is I divided by minus I square. I square is minus 1. So I divided by minus of minus 1. So that is equals to I. Next one that we are going to see is I raised to minus 39, which I will be writing it as 1 divided by I raised to 39, which will be equal to 1 divided by I now square. So I square raised to 39 is there into I. So 2 into how much is 38? 2 ones are, right, 38. 2 nines are I raised to 19, which will be equal to 1 divided by I square value is minus 1. Minus 1 raised to 19 into I, which is equals to 1 divided by minus I, which will be equal to 1 divided by minus I into I divided by I, which is I divided by minus I square, which is equals to I divided by minus 1, which is equals to I. So here what we have done is, here just you can have a look, here what we have done is I raised to minus 39 is equals to 1 divided by I raised to 39. So that is equals to 1 divided by I square raised to 19. 2 nines are 18, so it is a 38, right, into I, which will be the same steps that we have applied here also. The same steps that we have applied here also, that we have see the applied here the same. So this is how you will be solving the problems based on this. Now the next type of the next concept that you are going to learn in complex number is the modulus and the conjugate of a complex number. Now here the modulus and the conjugate of a complex number. Now let z is equals to a plus ib be a complex number. Then the modulus of the complex number, which will be denoted by mod of z, is defined to be a non-negative real number that is square root of a square plus b square, that is mod of z will be root of a square plus b square, and the conjugate is will be denoted by z bar. This is will be read as z bar, that symbol, this symbol is read as z bar, and is the complex number a minus ib. So here if it is plus it will be minus here, and here in z if it is minus this will be plus, right? So regarding modulus and conjugate of a complex number, I will be dealing it in the next class. Thank you.